that's a term you probably used before, most definitely in Algebra 1, probably before that, and we've used some in here before. Mean, typically we could interchange that word with average. When we talk about mean, median, mode, that same kind of mean. This one's going to be a little different, and it is going to take on a different definition. So it's not just mean, it's geometric mean. That is the positive square root of the product of two numbers. So you're going to multiply them together, find the product, and once you've done that, you take the square root, and that's called the geometric mean. An example of this, and I'll show you how easy it is to do. We're going to find the geometric mean between 2 and 50. So as it says in the definition there, what we're going to do is multiply them together, and then we'll take the square root. It's as easy as that every time. So we're going to do square root of 2 times 50 equals 2 times 50 would give us 100, and equals, we get 10. And 10 would be the geometric mean between 2 and 50. So what we get when we found their product and then took the square root. We're going to apply this into triangles, and this is going to relate back to what we did in the last previous chapters. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. And I would like you to go ahead and sketch this real quick. We've got a triangle. In that triangle, first of all, we notice it is a right triangle. Got the right angle up in there. Then, through that right angle, I drew an altitude. It touched the right angle up here at the vertex, and then it came down here and formed a right angle with that side. When that happens, you're going to create two small triangles on the inside, and according to this theorem, they're going to be similar to each other and similar to the whole thing. And our next example will have us use that a little bit. With this one, we are going to write a similarity statement identifying the three similar triangles in the figure. We get the big triangle, EFG, and in that, I drew the altitude, which is segment FH. Usually the way I do this, it doesn't necessarily have to be what you do, but I think it's a little easier. Name the big triangle first, because we'll base kind of everything else off that. So I could call that triangle, I could go EFG. Similar to triangle. Doesn't matter which one we name first. Let's say I look at this triangle, it's over here on the left. Just like we've used similarity statements before, I just need to pick out what angle matches up with what angle. So I'm looking at the whole triangle, and then I look at what matches up with E. Well, on the smaller one right here, E matches up with E. So it goes first. On the big one, F is my right angle. When I look at that, on this smaller one, H is my right angle, so it has to go next. And then the only other one left, if I've already used E and H, and then I'm going to finish this by relating to the last one, the really small one, similar to triangle. Again, I look at what matches up with E. Well, it can't be G because G matches up with itself, so it's got to be F. H is again my right angle, so it has to match up with F. And then G matches up with itself, so it's going to go last. And that's how you'll do these. And depending on what you've got, they might have you write all three of them. You might just have to compare one to the other. Just do whatever it says. In this case, we've got a similarity statement. All three triangles represent the original and the two small ones. Something else we can do with this, the geometric theorem that we're going to have next gives us a way to find some missing measures. The altitude drawn to the hypotenuse of a right triangle separates that hypotenuse into two segments. And that should make sense. If you draw that altitude, it touches the side, so it's got to cut it into two parts. Well, what happens is, the length of this altitude is the geometric mean between the lengths of these two segments. Again, the length of the altitude is the geometric mean between the lengths of these two segments. So if you know the two segments, you just do their geometric mean, and you'll find the altitude. Now, we could also do with this, if I know the altitude and I know one of those parts, I could work backwards to find the other one. And we'll practice doing that both ways. The length of a leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So this gives us a way to find this even if I don't know the altitude. The length of the leg is geometric mean between the length of the whole hypotenuse and the part that leg touches. And remember, if you need to pause this, do so. Last example, we're going to use the properties we just looked at. So I've got a right triangle. Didn't really label it as far as vertices, but we don't need it. And then in this right triangle, I drew an altitude, and then I gave you a few different things. The legs, I don't know. I don't know leg C. I don't know leg D. The altitude, that's E. I don't know that. But I do know the parts of the hypotenuse. They're 24 and 6, and that's all I need to find those Michigan measures. And it really doesn't matter which one we find first. E is the altitude. So according to that theorem, we're told E is going to equal the geometric mean of the parts. So 24 and 6. So square root of 24 times 6. C is the leg, so it's going to be the geometric mean of the entire hypotenuse, which if I know this part's 24 and I know this part's 6, the whole thing's going to be 30 times the part that it's next to, so 24. And then D, I'm going to do the same thing, but instead of using the 24, I'll use the 6, because that's the part next to it. And then to finish, you just calculate. So you probably just punch these in. If you are going to type this into your calculator as one thing, make sure you use parentheses around this part, because your calculator is going to want to do the radical first since it's like an exponent. So use parentheses if you're typing into the calculator. And for E, you're going to get exactly 12. For C, go and round that to about, we'll go 26.8. And for D, you can round that to about 13.4. And that's how you do that. So it all relates to the geometric mean. As long as you remember how to do that, remember which ones relate, you should be all right. Your assignment over this part is 535, 1 through 35 odds. And this will be due after you come back from the long weekend.